In our previous recording, we spoke about categories of numbers, different bases, base 10, decimal, base 8 octal, base 16 hexadecimal, and base 2 binary. In this video, we will convert between bases. Binary. We know that binary contains one of two digits, either a 0 or a 1. The positions in the binary number system, the rightmost position, will be the ones position, just like any other number system. In binary, the next position over to the left will be the 2s. We're doubling it. The next position will be the 4s. The next position over will be the 8s, then the 16s, then the 32, 64, 128. Each time, we double it to get the next position. And we can keep going. To convert between binary and decimal, to convert from binary to decimal, the first step would be to write out the binary number. So in our example, we're going to have 11001. Under each of the binary digits, starting from the right, write out the powers of 2, just like I did on the prior slide. So 1 in the rightmost position, followed by a 2, followed by a 4, followed by an 8, 16. 1, 2, 4, 8, 16. The power of 2 that fits with each of these. Any place that we have a 1, we're going to write down the power of 2 with it. So we have a 1 here, so we're going to write down our 1. We have a 0, we're not going to write down the power of 2. We'll write down a 0. We've got a 0, we're not going to write down the power of 2. Another 0. We have a 1, so we're going to write down the power of 2, in this case an 8. We have a 1, we're going to write down the power of 2, the 16. Lastly, we'll add these numbers up. We're going to add up 8 and 16 and 1, and we're going to come up with 25. Let's do another one. Let's come up with a number 110, So this is going to be our 1's position, our 2's position, our 4's, our 8, our 16, and our 32's. So we do have a 1. We don't have any 2's. We don't have any 2's. We have a 4, no 8's. We have a 16, and we've got a 32. 32, 16, 4, and 1. 5, 11, 13, carry the 1, should give us 53. Okay. Write out the binary number. Write the powers of 2 under it. Any of the powers of 2 that have a 1, we write down its power. We did not write down the 2. We did not write down the 8 because they had zeros. And then we add up the values. Converting from decimal to binary, we're going to write out the powers of 2 until we get to the largest power of 2 that does not exceed the number. So if we're looking at the number 21, we have our 1, which is not bigger than 21. We have 2, not bigger than 21. 4, not bigger than 21. 8, not bigger than 21. 16, not bigger than 21. But 32, doubling 16 would be, so we don't write it down. We then look at it. Are there any 16s in 21? Yes, there's one 16 in 21. So we do the subtraction. Are there any 8s in 5? Nope. So we put down a 0. Are there any 4s in 5? Yes, we can fit it in once. So we subtract out our 4, and we come up with 1. Are there any 2s in 1? No. So we write down a 0. Are there any 1s in 1? Yes, there's a single 1. So 1, 0, 1, 0, 1 in binary is equal to 21 in base 10. Okay. If we look at binary, 3 bits, a binary digit, 3 bits will give us the 1's position, the 2's position, and the 4's position. In 3 bits, we can have all zeros, which is equal to 0. No 1's, no 2's, no 4's. In 3 bits, we could write down 0, 0, 1. A 1, no 2, and no 4's. That's 1. We can write down a 0, 1, 0. No 1's, a 2, and a 4. That's equal to 2. And we can keep going. If we write down 1, 1, 1, we have a 1 plus our 2 plus our 4, which would be 7. In 3 bits, we can represent the values 0 through 7. But notice that the values 0 to 7, we have 8 different values. The values 0 and the values 1 through 7 give us 8 values. Converting from binary to octal, we take the binary number and we break it up into groups of 3's. Why groups of 3's? Because in octal, we have the numbers 0 through 7. And in binary, we can write 0 through 7 in exactly 3 bits. So we separate these out from the right in groups of 3. Our 0, 1, 1, or 0, 1, 1 has the value 3. 101 has the value 5. 10, or in this case, would be the value 2. So 253 in octal is equal to 10101011. Converting from binary to octal, we group things in 3 bits. Converting from octal to binary, we look up the binary for each of the bits. A 3 is 011. A 1 is 001. And a 5 is 101. So 101, 001, 011 in binary is 513 in octal. If we look at 4 bits, we have the numbers, the values 0 through 15, which happens to be the values we have for hexadecimal, base 16. We have the 1s, the 2s, the 4s, and the 8s. So if we look at the binary number 1010, we have an 8, no 4, a 2, and no 1s. 8 and 2 is 10. But if we're doing it in hex, we would write down the letter A, not the digits 10. If we had the binary number 1110, and we wanted to convert that to hexadecimal, we have these 4 bits. We have an 8 and a 4, which is 12. A 2 gives us 14, and there's no 1s. So 14 gives us the value which we represent as an E in hexadecimal. Converting from binary to hexadecimal, we break our numbers up into groups of 4. So a 1011. 1011 has the value of 11, but we represent it with a B. 1011 to 1010 has the value of 10, which we represent with an A. So this number, base 2, is equal to AB in base 16. To convert from hex to binary, we will take the numbers, look them up, and write them from right to left. The number 2 is 0011. The value C is 1100. And the value 3 is 0011. But just like in base 10, we don't write our lead zeros. So this number, base 2, is equal to that number, 3C2, in hexadecimal. If you have any questions, let me know. That's it for today.